In our last example, we talked about how you could use PV equals nRT to find a number of moles of gas. And if you can find moles, then you can do stoichiometry. So let's talk about how to do that now in this section. We've discussed stoichiometry twice before. We talked about it in chapter 3 when we first introduced stoichiometry, and again in chapter 4 when we did solution phase reactions. There's a general strategy that you'll use for solving stoichiometry problems, and I'm just going to take a moment to remind you what that is. We begin by writing a balanced equation for a chemical reaction that occurs. Then we find moles, and then from there, you would use the mole ratio from the balanced equation to convert the moles of whatever the problem gave you into the moles of whatever you're looking for. This strategy is pretty much the same regardless of whether you're solving a stoichiometry problem from chapter 3, 4, or 5. The difference comes in when it deals with how we find the moles or how we use the moles. So for problems in chapter 3, we were often given grams, and so you would use a molar mass to convert the mass to moles. In chapter 4, when you were dealing with solutions, you were given molarities and volumes, and so you have to multiply volume times molarity to find moles. And here in chapter 5, when we deal with gases, the ideal gas law is going to come into play when we're finding moles. Other than that, the strategy for solving the problems is pretty much the same. So this is one last chance to really get some practice with stoichiometry to really nail down this concept in this method. In this problem, we're going to say our reaction is calcium reacts with 2HCl to produce H2 gas plus calcium chloride aqueous. You're asked to determine what volume of hydrogen gas is produced if 0.27 moles of calcium reacts with 0.35 moles of hydrochloric acid at 50 degrees C and 0.85 atmospheres. And you're told you can assume the reaction goes to completion. Now, in this problem, we have a balanced equation, and we have also been told the moles already. We've been given the moles of our two reactants, calcium and HCl. Based on that, we can identify what type of a problem we're dealing with here. Right? We recognize that if you're given the amounts of 2 or more reactants, we're dealing with a limiting reactant problem, right? When you're given the amounts of 2 or more reactants, you have to figure out which one is limiting. So that's what we need to do. First, find the limiting reactant here. To do that, we're going to convert the moles of each reactant into moles of product, and whichever one makes the least product, that's limiting. So for the calcium, we have 0.27 moles of that. And the mole ratio tells me that I make 1 mole of H2 for every 1 mole of calcium. And so if you use up all of the calcium, then you would make 0.27 moles of H2. All right, what about the HCl? So for the HCl, we have 0.35 moles of that. And the mole ratio from this equation tells me I make 1 mole of H2 for every 2 moles of HCl. And so the moles of HCl cancel out, and I find that if I used all the HCl, then I would make 0.175 moles of H2. Whichever reactant makes the least amount of product is limiting. We can't get to 0.27 moles of H2 because you use up all of the HCl when you get to 0.175 moles of H2. So what we say is that HCl is the limiting reactant, and we can say you make 0.175 moles of H2. With that in mind, we now can finish solving the problem because the problem is asking us what volume of H2. So lastly, we will now use PV equals nRT to convert moles into volume. All right, so when we use PV equals nRT, we're trying to find volume, so we have to divide both sides of the equation by pressure. That solves for volume. Volume is equal to nRT over P. We know that we have 0.175 moles of gas, right? That's what we found from doing the stoichiometry. For R, which R do we use? We recognize that in the problem we have a pressure in atmospheres, right? So if you see atmospheres, then R needs to have units that contain atmospheres. We want to use the small r, 0.08206 liters atmospheres over mole Kelvin. Temperature, we're told it's 50 degrees Celsius, but remember that in the ideal gas law, we always want to use Kelvin. So we would convert the Celsius to Kelvin. 50 degrees Celsius is 323 Kelvin. So 323 K. all over the pressure of 0.85 atm. For the units, moles cancel, Kelvin cancel, atm cancel, and all that we have is liters. Good thing, because we're finding a volume. And what we find is that the volume of the H2 generated is 5.5 liters. And there we have it. Just one more opportunity to get practice with doing stoichiometry, this time in the gas phase. And the only difference here is that instead of using a molar mass as a conversion factor or using a molarity as a conversion factor, here we're using PV equals nRT as our method of converting between, in this case, moles and a volume of gas. Next up, we'll begin talking about mixtures of gases.